Hey guys, welcome to Friday, TOC 511. So today we are talking about quadratic functions and connecting them to different representations, mostly drawings, but we also have a couple tables. So I probably should have put that in there. All right, let's get to it. So if you remember, quadratic functions always focus on squares. I know it's a quadratic function because it always has an x squared in there. And in fact, the standard form, just like y equals mx plus b is the standard form for linear, we have y equals ax squared, right? Sometimes we got a fraction, sometimes a number, sometimes 1, plus bx plus c, which is our constant. Cool. So that's something to write in your notes if you have them. All right, so the fifth term, I have a 1 white square, and then it makes a total of 4, right? So here I've got a 2 by 2 square, and a total is a 3 by 3 squared, right? So when I'm doing the fifth term, instead of going 1 white circle, 2 white circles above, 3 white circles above, right? 1, 2, 3. I'm going to have 4 white circles. 1, 2, 3, 4. And I'm going to make them a square, just like this is a square. It's a 3 on top, and then 3 on the side. 1, 2, 3. So here I'm going to have 4 on the top. 1, 2, 3, 4. And 4 on the side. So the top one counts again. 1, 2, 3, 4. And I'm just going to fill in that square. So this is a 4 by 4 square, which means I will have 16 circles because 4 squared is 16. Now, I add on another layer of gray dots, which I guess I'll just color in. So 1, 2, 3, 4. But now I'm making another layer to make the whole thing a 5 by 5 square, which means 25 total circles. All right, so I got 16 or 4 squared white circles and 25 or 5 squared total circles. Example set 1. This is somewhere on your worksheet, so try to find it. So again, I'm focusing on the squares and then any constants that are happening. So in this one, I've got 1 square, so 1 squared. And here I've got 1, 2, 3, 4, which is what 2 squared is. 2 on the side, 2 on the top. All right, here I have 3 squared in the white boxes, so I've got 3 across, 1, 2, 3, and 3 on the side, 1, 2, 3. All right, so 1 squared, 2 squared, and 3 squared. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is what 3 squared is. Now, if you notice, we've got these guys over here. All right. And again, I'm going to write that original ax squared plus bx plus c. Now, those 2 squares on the end that are gray, those are constant. It happens in every single term. I have 2 gray boxes. All right. So I'm just going to add those 2 here. All right. Now I've got to get my equation. I know that because 2 is constant in all of them, I'm going to have a plus 2 here. Now, I look at the square terms. I've got 1 squared, which gives me 1 box. 2 squared, which gives me 1, 2, 3, 4 boxes. and 3 squared, which gives me 1, 2, 3, 4, 5, 6, 7, 8, 9. The important thing to do now is to connect it to the x terms. Now, what are the x terms? The x terms are always going to be your term number. So my x terms are always going to be this top row. Right? And that's the same for these guys too. Okay. So I have a 1 squared and my x value is 1. I've got a 2 squared, my x value is 2. Same for 3. 3 squared, my x value is 3. So because they match, I just have to put x squared in here. All right, so my full equation is f of x equals x squared plus 2. All right, so now for the second one. If you notice, the first one doesn't have anything, right? The second one is a 2 by 2 squared, but it's actually missing a block that would make it a full 2 squared. So it's kind of like 1, 2, 3, 4, which is what 2 squared is, minus 1, right? That one doesn't actually exist. And this guy, it's really a 3 by 3 squared, but again, it's missing, and the important thing is it's missing the same 1 square that 2 was. All right, so now this is a 3 by 3 squared, 3 by 3, which is 9, right? 3 squared is 9. So let me look. 1, 2, 3, 4, 5, 6, 7, 8. And the 9th one is being taken away. So minus 1. All right, so what about the first term? What happened there? Well, think about it for like 2 seconds. What do you think is going to be there? All right, so if you said 1 squared minus 1, you are correct. So I'm following that pattern, 3, 2, 1, right? So here I really could have had 1 squared, but then 1 squared is 1, and then I subtract 1, so it doesn't actually exist. So I look. When I've got 2 squared, my x value is 2. When I have 3 squared, my x value is 3. And when I have 1 squared, my x value is 1. So they match, so it's the same thing, x squared minus 1. All right, example set number 2. Let's get it. All right, so here I have 1 squared, right? 1 squared is 1. Here I've got 2 squared. 2 squared is 1, 2, 3, 4. And 3 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. That was pretty easy. So now I'm going to look at my x values, right? These are the x's. Now, 1 squared is not 3. 2 squared is not, 2 squared is 4, but 2 itself, right, if I was to replace this with x, it's not x. X is 4, it's not 2. All right, and same with 3. Here, it's 3, but it doesn't match the x because the x is 5. So whenever you have squares, but it's not matching with your x's, that is when you've got to put it inside of the parentheses with the x, because we're actually changing the x value before we square it. Think of your order of operations. You do what's inside the parentheses before you square it. So to turn this 3 into a 1, I'm going to take away 2 from it, right? So 3 minus 2 gives me that 1. All right. Now over here, my x value is 4. 4 minus 2 is 2. And then I can square it. Once it's at 2, then I can square it. And 5, oops, what did I do? All right. So 5 minus 2 is 3. And now I can square it. So my equation, and try and write it down before I do, is f of x is equal to whatever x value is minus 2. And then I get to square it. All right. So again, feel free to pause, but we're going to truck right along here. So here I see my squares. I see 1 square, and I see 1, 2 on the side, 1, 2 on the top. So this is a 2 by 2, which is 4, right? So, and here I've got a 3, 1, 2, 3 by 3. All right, so I see all of my squares here. So here I can say 1 squared plus 2. All right, I got plus 2 gray ones. 2 squared plus another 2. So this looks like a constant. That's pretty cool. Okay. And then 3 squared plus that constant value of 2 again. And we've got the same issue that we had before. So if my x value is a 4, I actually want to change it to a 1. So what am I going to have to subtract? Think about it, guys. All right, so we have x, whatever that x value is, minus 3. And then I'm going to square that. So 4 minus 3 gives me 1. And now I do 1 squared. Okay, 5 minus 3 is 2. And then I square it. All right, and then I don't want to forget my constant, those same 2 gray squares at the end. All right, so let's get going to example 4, and now we have a table. Excellent. All right, I can't tell what the vertex is, but I can tell an x and y intercept if you want to go extra and find it. But let's stay focused. Okay. So here I've got all of these terms, right? I got all these x's and y's. So what I'm going to do is I'm going to treat it like a sequence, right? I'm going to say 1, 2, 3, all right? So 1, 2, 3. And then I'm going to actually draw out the boxes. I'm really just taking a sample, right? I don't want to draw 15 or 24 boxes if I don't have to. And I like starting with the first term because 0, while it is absolutely fantastic to have in a function, if I'm writing out a sequence, then 0 is not really part of that. All right, so now I have my first term has 0 boxes. That's pretty easy. All right, I'll take that. My second term has 3. So I've got 1, 2, 3. Okay. My third term has 8. So I'm going to put 1, 2, 3, 4. And I'm building it in a square as much as I can, right? There's a reason why I made 1, 2, 3, 4 like a square. So now I got a little bit more than 4. So 5, 6, 7, 8. Now I got to stop. All right. So let's see what I got here. So I have the second one is almost a 2 by 2, but again, it's missing 1. And the third one is almost a 3 by 3 or 3 squared, which is 9, remember, but it's also missing 1. All right, so let me see if I can figure this out. So this is almost a 2 by 2 or 2 squared, which is 4, 1, 2, 3, 4, but it's missing that 1, so minus 1. And this one is a 3 by 3 or 3 squared, which is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. But again, it's missing that 1, so minus 1. Oh, and this looks kind of like the function that we had before. All right. So now I know that this is 1 squared, which is 1, right? One box, but minus 1 takes it away. And that would leave me with 0 boxes, which is a good thing because that's how many I should have. All right. So the equation for this would be f of x is equal to, oh wait, do the x's match? Do the x's match the squares? 1, 1. Ah, they do. Okay, that makes it easier. X squared minus 1. All right, let's get to the last one, I think. Oh, yeah. Okay. So, sorry, this should be example set number 5. All right. So, we have, we're going to have to do a lot of boxes. All right. So, again, I kind of want to just start with where x is 1. And I want to draw like as few boxes as I can. All right. So, my first term, my second term, let's see if we can fit all of these. Let me do it one at a time. All right, so I am trying to build it like a square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so the first term has 11. The second term has 14. So I'm just going to do this. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, and then the third one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right. So on the positive side, I feel like this is going to be the trickiest one we got. All right. And so we're still looking for that pattern of like 2 squared, 3 squared, 4 squared, 1 squared, 2 squared, 3 squared. So we're looking for some kind of term that's squared. All right. And so here it actually is 1 squared. And here it's 2 squared. And here it's 3 squared. And I have no doubt that you guys would get there, right? And we're just moving a little bit faster because of the video. So the reason that it's 1 squared, 2 squared, and 3 squared is because if I count the leftovers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 left over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 left over here too. So there's where I'm getting my constant. This is just kind of a bigger constant than we're used to. And here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for the third term, I also have a plus 10. And I'm left with squares, right? So I have 1 squared plus 10, 2 squared plus 10, and 3 squared plus 10. All right, so remember 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 10 gives me that 19. For the second term, I have 2 squared, which is 4. 1, 2, 3, 4. Plus 10 gives me 14. And here, 1 squared plus 10 gives me that 11. All right, so it's kind of cool to like investigate. I was drawing this out before I came on this video, and I had to play around with it a little bit and just think, hey, what's going on? It doesn't look as easy as it normally did, right? And that's okay. That productive struggle is part of how it gets and stays in your brain. Now, I'm expecting a lot of questions, comments, concerns. So please write them down. Don't forget them. I want to give a shout out to those of you that have been putting your notes in your note tracker. I see you. I've made some comments on some of yours. If I haven't, you'll probably get either a reminder or comment soon. So really good job following along, guys. I will see you on Monday.